Welcome back. This is part 2 where we will start the single cycle Datapath with load word instruction. One thing to be noted before watching this video, please watch the early video of part 1. There are two separate videos that explain the background of this presentation lecture. Well, let's start this. So this is a bit complicated, but try to understand it in a very easy way. Okay, I will explain this data path in a very precise and easiest way so that you guys can easily understand this. Well, we have three things to keep in mind. First, we have an instruction. That means we have a load word instruction with a 32-bit binary data. So, and this is the data path to execute this instruction. And throughout this lecture, we will try to understand this data path. One thing to be noticed here we only consider data path, but on top of data path, we have also the controller, right? But to make it simple, we don't use the control circuit here. So for today, we will only consider the data path and their flow. One more thing, keep in mind, I make two colors, the blue color and the green color, so that throughout the presentation, the blue part is considered as a memory element and this green part is a combinational circuit. Okay, so let's start load word instruction data path. Okay, so we will follow some basic steps and these are the summary. So we have 5 major steps and this is optional steps, not related with this, but this is just to face the next instruction. So we have 6 basic steps. Perhaps I can say that it's 5 basic steps. So in the first part, we will face the instruction from the memory. So what we going to do? Keep in mind, we want to explain the data path for load word instruction. So before going to do that, you can see what load word instruction do. It load a data from the memory to a particular register. To do that, we need the 5 steps. First, fetch the instruction from the memory. Okay? And based on the instruction, we need to read the source operand from the register file. And we need to calculate the memory address. To do these, we need to extend the sign of the immediate that includes the instruction. We need to compute the memory address and write back to the register file. So these 5 is the basic steps and we will go through individual of all. Well, the first part, fetch instruction from the memory. Keep in mind that we have a 32-bit instruction, particularly here, this instruction, load word T2. So here what we can see, this 32-bit instruction, and there are several parts of this instruction, of course, we have studied. So here you can say that the program counter face this address is stored here, and in the address we have this instruction. Okay, so this is the instruction, load word instruction in this address. So perhaps we can say it like this way. So this is the address, and this address contains this data, and this data means we have this instruction, right? So what we're gonna do in the first phase, the instruction that as the program counter contains this address and the corresponding data is this, so we find this address here. So this is the end of first step, fetch instruction from the memory, because The program counter contains this address, this address contains this value, and this value is our target instruction that we are building the data path, right? Well, the second step is now we need to read the source operand register file, right? So here in this instruction we have source operand, right? Here, where basically for the load word instruction, the base address is stored. Okay. Here, in case we use 0, because our base is 0, so we are looking for an address of 32, because the memory address is basically the base address plus the offset. So in particular case, we know that we are 32 will be the memory address, but if it is not S0, if it is S1, then we have to go to the S1 to find the value of base, and then we need to add this offset with the base address, right? So in particular case we have 0, and the address of the register is here. So bit 25 to 21 is the 5 bit that shows the address of the source register. So here we read this part, that means in the A1, so we will get the value of RD1. So A1 received the address of 0 register, so we will get the 0 here. Again, I want to explain here to clarify you, if here is other register like S1 or S2 or any other, so we will come here and find the value of this particular register, and we will get this as a base address. Okay, so we will find this base. Now we need to add the offset. Well, to add the offset, here is the immediate value of 16 bit, right? So one thing keep in mind, that where we are in program counter, we could go even upper and then lower address. So this is an immediate value that could be either positive or negative. In our case is a positive value. It could be even minus 32. Okay, so whatever the case is, the immediate is the offset for this instruction that could be added. If it is negative, the memory address is reduced. If it is positive, the address is increased. So it's a 2's complement format. So we need a particular combinational circuit here that extend this 16 bit to a 32 bit. And if the number is positive, so it added all zeros. And if the number is negative, it is added all the 1 before the value. So this is 16 bit. Another 16 bit is filled either by 0 or by 1 based on the offset value. If the offset value is negative, the initial all the bit will be the 1, otherwise 0. So in our case it will be the 0. So we are in step 3 and we now extend the sign. Then in step 4 we will calculate the address of the memory, right? Because the load word instruction basically load the data from the memory address to a particular register, and here we tell the register is T2. Well, so we need to add the offset with the base address. The base address is 0 here in our case, and we'll find the offset. Now let ALU, I mean arithmetic logic unit, comes up. So arithmetic logic unit is not an adder here, but it's performed as an adder because the control unit here says a particular value. So the arithmetic logic unit do we choose operation and the arithmetic operation. So based on the value of the contour. So 0, 1, 0 is particularly used for the adder. So it add this value, and here we will find the memory address, because we add the offset with the source address, base address. So that's it, we find the memory address. Now the data memory we have studied, we can easily find the data, and then we need to store it to register. This is the last phase, okay? So write back to the register file. So once we get the memory address, we find the data, and here the register file is now used in the different mode. We use the A3 here, and that contain this bit 20 to 16 here. And this is the address of the destination register, where we need to store the value from the memory. So in particular case, we need to the write operation. So this flag will be 1 enable, and in the clock raising age, this value is stored to the temporary 2 register, and that's it. So this is the way we can compute the load word instruction. So we first fetch the instruction, and then we select the source register to calculate the address of the memory. From the immediate part, we extend and add it here, and then finally we write the value in the register file. So, and the last but not least is the program counter is added to fetch the next instruction. And this is all for today. If you have any question, contact me with a Moodle or email, and solve the classwork after understanding this. That's all for today. See you in the next class.